In a previous lesson, we learned about the signs and the quadrants of the unit circle and the signs of trig functions in the unit circle. You may wish to pause the video at this point and refamiliarize yourself with the concepts in these two slides before moving on. In this example, we're told that the sine of theta equals -2/3 and that the tangent of theta is greater than 0. In other words, the tangent of theta is positive. Then we're asked to find the cosine of theta and the cotangent of theta. Note that the sine of theta is negative in quadrants 3 and 4, and that the tangent of theta is positive in quadrants 1 and 3. The only quadrant in which both of these occur is quadrant 3. The sine of theta is negative in quadrant 3, and the tangent of theta is positive in quadrant 3. Therefore, theta lies in quadrant 3. If we look at the image of the triangle below, as if it were positioned in quadrant 3, we can then use the information given in the problem to label the sides. So we have an angle theta, and we're told that the sine of theta equals -2/3. So since sine of theta equals opposite over hypotenuse, we know that the opposite side is 2 and the hypotenuse is 3. And because we're in the third quadrant, the 2 is negative because the y value is negative in the third quadrant. Now we can use the Pythagorean theorem in order to find the missing side of the triangle. If we assume that the missing side of the triangle is x, then we can say that x squared plus -2 squared equals 3 squared. Then x squared plus 4 equals 9. So x squared equals 5 if we subtract 4 from both sides. And therefore x equals plus or minus the square root of 5 if we take the square root of both sides to solve for x. But because x is negative in quadrant 3, we know that x is equal to the negative square root of 5. We can throw out the positive square root of 5. We can label that on our diagram here. Now that we know all three of the lengths of the sides of the triangle, we can find the cosine of theta and the cotangent of theta. The cosine of theta is equal to the adjacent side, negative square root of 5, over the hypotenuse, 3. The cotangent of theta is equal to the adjacent side, negative square root of 5, over the opposite side, -2. The negatives cancel out, and we're left with the square root of 5 over 2. Go ahead and pause the video and try this problem on your own. In this problem, we're told that the tangent of theta equals -15 over 8, and the sine of theta is less than 0, where the sine of theta is negative. We're asked to find the 6 trig functions of theta. The first thing we need to do is to find the quadrant in which theta lies. We know that the tangent of theta is negative in quadrants 2 and 4. And we know that the sine of theta is negative in quadrants 3 and 4. So the only quadrant in which both of these occurs is quadrant 4. The tangent of theta is negative in quadrant 4, and the sine of theta is negative in quadrant 4. Therefore, theta lies in Q4, or quadrant 4. Now we can draw a diagram to help us better visualize this. We know our angle is in quadrant 4. We're looking at a fourth quadrant angle, which means theta is here, and our reference angle is here. And we're told in the problem that the tangent of theta is equal to -15 over 8. Since the tangent of theta is equal to opposite over adjacent, we know that this side is 15 and the adjacent side is 8. We know that 15 is negative because the y value is negative in the fourth quadrant. Now we need to solve for the hypotenuse. We know that we can use the Pythagorean theorem, and since we know that the Pythagorean theorem tells us that the base of the triangle squared, 8 squared, plus the height of the triangle squared, negative 15 squared, equals the hypotenuse squared, r squared. 8 squared is equal to 64. Negative 15 squared is equal to a positive 225. And the sum total of the two is 289. So r squared equals 289. In order to solve for r, we can take the square root of both sides. So r equals plus or minus 17. But we know that the hypotenuse, or the radius of the circle, is always positive. So we can throw out the negative, and r equals a positive 17. We can label that in our diagram here. And now we know all three sides of our triangle. So now we can find the 6 trigonometric functions. We know that the sine of theta equals the opposite side, negative 15, over the hypotenuse, 17. Cosecant of theta equals the hypotenuse, 17, over the opposite side, negative 15. Cosine of theta equals the adjacent side, 8, over the hypotenuse, 17. The secant of theta equals the hypotenuse, 17, over the adjacent side, 8. The tangent of theta equals the opposite side, negative 15, over the adjacent side, 8. And finally, the cotangent of theta equals the adjacent side, 8, over the opposite side, negative 15.